Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, subscribers, viewers, and students. Here is a problem on space thrust. Let's analyze the space thrust shown by determining all support reactions and member forces connected to joint C, D, E, F, and G only. We will determine all member forces also. Summarize your final answers in a box. So here is the given figure. First, let's find zero force members. So as our guide in analyzing this thrust, so let's have the 3D view, pictorial view. These are the reactions, the orange ones, and let's assume the component reactions are all in the positive directions. These are the loads also and the letters. So if we analyze at first at joint F, F is unloaded. There are four members meeting at F and three members will lie on the same plane. So FG is the only member that is off the plane of the three. Therefore, by principle, FG is 0. Likewise, if we proceed to joint H, H is also unloaded. All There are four members and three members will lie on the same plane, these members here, and therefore EH is also 0 as indicated here. So FG0, EH is 0. So as our answer SEH0, SFG0 for these two members. Then we begin at joint G. We cannot solve any of the reaction components here. So we will compute member forces first, then last the component reactions. We begin at G uh, because this is 0 and the 90 kilonewton load is collinear with HG, and remember that GC and BG are on the same plane. So by experience, this HG here is expected to be 90 kilonewtons, and therefore by principle in statics, two forces in equilibrium may be added to any system without changing the effect of the original system, or they may also be removed because they are in equilibrium. If removed, so imagine that there's no 90 kilonewton load and there's no Hg. Since this is 0, Fg, there will only be two unknown forces at G. And by principle again, the two unknown forces that are in equilibrium will be zeros. But we will prove that by setting up equations of statics at G. So by the way, distance Cg is equal to distance dH equal to distance AE and distance BF. So distance CG is square root of 2.5 square plus 6 square along Y, then plus 2 square along Z. 2.5 square plus 6 square plus 2 square. So all these distances are equal. Distance CG, which is equal to DH, distance AE, distance BF is square root of 46.25 meters. Then distance BG is equal to distance DE. It is square root of 2.5 square plus 6 square plus 6 square. So distance BG equals distance DE. So along X 2.5, along Y 6, and along Z also 6. So square root of 2.5 square plus 6 square plus 6 square. And that is equal to square root of 78.25 meters. We then set up equation at G. These are the colored forces. This is 0, so not colored anymore. So we begin with SCG times 2.5 over square root of 46.25, that's the x component, then plus SBG times 2.5 divided by square root of 78.25 minus SHG or SGH, then plus 90 equals 0. So plus 90 equals 0, so equals negative 90. Call that equation 1. Summation forces y equals 0. 90 and GH are on the horizontal plane, so GC is downward, GC going down, GB is also going down, so treat downward as negative, downward along y negative, so negative SCG times 6 over square root of 46.25 negative SBG times 6 over square root of 78.25 equals 0 plus 0 SGH. Let's involve SGH equals 0. Equation 2. And finally, summation forces along Z. This is the positive Z direction. Positive Z direction. Positive Z direction. So SCG is negative. So negative SCG times 2 over square root of 46.25. SBG is positive towards the positive Z direction. So plus SBG times 6 over square root of 78.25. Then SGH is not involved. So plus 0 SGH equals 0. Equation 3. Solving these three equations simultaneously gives us the following results. As expected, SCG is 0, SBG is 0, and SGH is indeed 90 kilonewtons. So you can verify that using your calculator. So having found the forces at joint G, we proceed to joint H. At joint H, there are only two unknown forces. We need distance CH, and distance CH is equal to distance AF square root of 7.5 square. So these are the unknowns, and this is 90 kilonewtons. Distance CH square, distance AF, CH equals distance AF square root of 7.5 square plus 6 square plus 2 square. So 7.5 horizontally, 6 vertically. Take note, the vertical distance, the height of the space truss, and along Z2 also, so 2 square. So it is equal to square root of 96.25. Take note, it is also equal to distance AF. Then distance DH is equal to distance CG, so it's already here. Summation forces X equals 0, so SCH times 7.5 over square root of 96.25. SDH is negative, so minus SDH times 2.5 over square root of 46.25 plus 90 equals 0, so equals negative 90, equation 4. Summation forces along Y equals 0, or it may be along Z. So negative SCH times 6 over square root 96.25. This is summation forces along Y. So CH is going down from going down because we begin at H. SDH going down also because this is the top point. So minus SDH times 6 over square root of 46.25, then equals 0, equation 5. Since these are the two equations into unknown, solving the two equations simultaneously gives us SCH equals negative 88.30 kilonewtons, SDH equals 61.21 kilonewtons. Then from here, we proceed to joint E. Summation. Let's check summation forces along Z because it is not used. So both are negative. So negative of SCH, negative of SCH, SCH is negative 88.30. Z component of distance 2 divided by distance square root of 96.25. SDH is negative also, SDH. So minus, because it is in the opposite Z direction. So minus 61.21 times 2 over square root of 46.25. So computing using your calculator, it is 0. So it's okay. So meaning to say our answers so far are correct. We then proceed to joint E, and these are the unknown forces except this one because this is 0. So summation forces X. So distance DE is equal to distance BG, and we already computed that, which is equal to this. And AE is also equal to CG, already computed. So summation forces X equals 0. SEF first, rightward, minus SDE times 2.5 over distance, which is equal to SDE. SDE is equal to SBG, and it is equal to square root of 78.25. Then minus SAE times 2.5 over square root of 46.25 equals 0. So call that equation 6. Summation forces Y equals 0. SEF is horizontal, so it is 0. So 0 SEF. Then SDE is going down, so minus SDE times 6 over square root of 78.25, where 6 is the Y component of distance of SDE. SAE, the Y component of distance is also 6, but it is going down also, so minus SAE times 6 over square root of 46.25. Take note that there is a downward load of 150 at E, so minus 150 equals 0. Transpose minus 150 to the right, so equals 150, equation 7. Then summation forces along Z, SEF again is not involved, so 0 SEF. Then SDE is negative in the opposite Z direction, so minus SDE times 6 over square root of 78.25, then plus SAE times 2 over square root of 46.25, it's positive, then equals 0. Equation 8, solving equation 6, 7, and 8 simultaneously, we can now compute SEF equals negative 62.5 kilonewtons, SDE equals negative 55.29 kilonewtons, and SAE equals negative 127.5 kilonewtons. So on the next slides, let's have this same figure and these answers, partial answers, so that we can use them on the remaining members and reaction forces. So from the preceding slides, these are the results, including the distance of CH. Let's have it also here. So we proceed to join F. Take note that SEF is negative 62.5. It's already here. So these are the new unknowns, SBF and SAF. Since S distance AF is equal to CH, that's why I rewrite distance CH here. So BF is equal to CG DH AE. So summation forces X equals 0. SBF times 2.5 over square root of 46.25 minus SAF times 7.5 over square root of 96.25, the distance, which is equal to CH also, minus negative 62.5, so it becomes plus 62.5 equals 0. So transpose 62.5 to the right, so equals negative 62.5, equation 9. Then summation forces Y, BF downward, AF downward, 62.5 is not involved, negative 62.5 is not involved. So we'll have only two equations to announce here. So SBF, negative times 6 over square root of 46.25, where 6 is the y component of distance, minus SAF times 6 over square root of 96.25. Then there's no load here, equals 0. Equation 10. Solving these two equations simultaneously, we have SBF equals negative 42.5 kilonewtons and SAF equals 61.32 kilonewtons. So after joint B, we proceed to joint C. Let's check by summing up. Let's use this static equation at F. Summation forces along Z equals 0 in the positive direction BF, but the sign is negative 42.5, so times 2 Z component of distance over distance, square root of distance, over distance. SAF is also in the positive Z direction, so plus 61.32 times 2 over square root of 96.25. So checking, summation forces Z equals 0. So okay, so far our answers are correct. Then we proceed to joint C. So these are the unknowns, orange ones. Remember that CG is 0. Yes, CG is 0. So summation forces X, SCD is negative, SCH is also in the negative direction. Only these two forces are involved. So negative SCD, let's solve for the vertical reaction first. CY, assuming upward, then plus SCG, which is the only force that is involved, but its sign is negative. SCG is 0 rather. SCH is in the upward direction, but its sign is negative. So CY plus negative 88.3 times 6 over square root of 96.25. Y component of distance for CH, and this is the distance CH. Then no more equals 0. So from there, we can solve CY, and because it is positive, it is upward. Summation forces X equals 0, negative SCD, then minus SCH, so minus quantity, negative 88.3 times 7.5 over distance, square root of 96.25. Because SCG is 0, SCH is this one, negative 88.3. So 7.5 over square root of 96.25. The X component of SCG equals 0. So from here, we can solve SCG, and it is positive 67.5 kilonewtons. Summation versus Y, summation versus X. So summation forces along Z to solve for SBC. SBC is positive, assume. SBC plus SCG times 2 over square root of 96.25. Then no more equals 0. So SBC plus negative 88.3 times 2 over square root of 96.25 equals 0. No more because SCG is 0. So SBC can now be solved. It is equal to 18 kilonewtons. We then proceed to joint D. So these are the unknowns. Let's solve for dx first. Summation forces horizontal, because we already found dh and de. This is SAD, not yet involved. So summation forces horizontal, dx plus SCD, which is 67.5, plus SDH, which is SDH 61.21 times 2.5 over square root of 46.25 plus SDE, and SDE is negative, so plus negative 55.29 times 2.5 over square root of 78.25 distance equals 0. So we can now compute dx. dx is equal to negative 74.38 kilonewtons. Summation versus y, let's assume dy as upward. dh is upward, de is also upward. So dy plus sdh, this is 61.21 times 6 over square root of 46.25 plus sde plus negative 55.29 times 6 over square root of 78.25 equals 0. So dy is equal to negative 16.5 kilonewtons. Then summation forces along z SAD in the positive direction, assuming this direction, positive SDH also plus 61.21 times 2 over square root of 46.25 plus SDE, which is negative 55.29 times 6 over square root of 78.25. Z component of distance of DE is also 6, then equals 0. So from there, we can solve SAD, and it is equal to 19.5 kilonewtons. We then proceed to joint B. Let's prepare A first, but we cannot solve AX there because we don't know AB yet. So we proceed to joint B to solve for AB as shown. So I'm not highlighting BG because it is 0. BG is 0. So summation forces X SBF was already found, and it was negative 42.5. So summation forces X equals 0. SAB is to the left, so negative SAB. Then minus SBF, so minus negative 42.5 times 2.5 over square root of 46.25 distance. Then no more equals 0. So SAB is positive 15.62 kilonewtons. Having found SAB, we have summation forces Y to solve for BY. So BY is upward, SBF is also upward, the only force that is involved. So BY plus negative 42.5 times 6 over square root of 46.25 equals 0. So from there, we can solve for By, and By is equal to 37.5. Positive means upward kilonewtons. Then, let's solve for Bz. Summation forces along Z equals 0. So let's assume that Bz is in this direction, so positive direction. So Bz, then minus SBF. SBF is negative 42.5 times 2 over square root of 46.25 minus SBC, and SBC is negative 18 equals 0. So solving for BZ, BZ is equal to 5.501. So let's just call it 5.5 kilonewtons. Let's just round off that to 5.5 kilonewtons. So on the next slide, we proceed to joint A, and let's have all these answers also copied on the next slides. So this is the figure, then the calculated values from the preceding slides. We now proceed to joint A, summation versus X, and assume AX in the positive direction. So AX plus AE, SAE, which is equal to negative, so plus negative 127.5 times 2.5 over distance square root of 46.25 plus SAF. SAF is 61.32 times 7.5 over square root of 96.25 SAF, distance AF. So 61.32 times 7.5 over square root of 96.25. Then plus SAB, and SAB is 15.62 equals 0. So from there we can solve AX, and AX is negative 15.63 kilonewtons. We can now check the whole system summation versus X if it is 0. So summation versus X equals uh, this is dx, negative 74.38 dx, then plus AX, which is negative 15.63, plus 90, the load rightward, then it is 0, almost 0. So that's okay. Then let's solve for AY. Summation versus Y. AY is assumed upward. AE and AF are also upward, but you have to take the sign. So AY plus AE, SAE, which is negative. So plus negative 127.5 times 6 over square root of 46.25 plus SAF. SAF is 61.32 times 6 over square root of 96.25, the distance AF, which is equal to CH. Then equals 0. So from there, we can solve for AY. AY equals 75 kilonewton, so it is upward. We can now then check, because everything is found for vertical reactions, AY, BY, CY, and DY. If the sum is 0, so summation versus Y equals 75 plus BY 37.5 plus CY 54 plus DY negative 16.5, then minus 150, the load. So summation versus Y is 0. So that means we are sure that all the preceding member forces values and other reactions correct. Then finally, let's solve for AZ. Summation at A, summation forces along Z equals 0. So AZ is assumed to be positive. AZ, then minus AE. So minus SAE, and SAE is negative. So minus negative AZ minus, minus AD first, because we have AD 19.5. Then minus SAE, which is minus negative 127.5 times 2 over square root of 46.25 distance. Then minus SAF, and SAF is 61.32 times 2 over square root of 96.25. Then equals 0. So AZ is equal to negative 5.5, round off. Then we check summation forces along Z. Along Z, we only have AZ and BZ. So AZ is negative 5.5, while BZ is 5.5. So obviously it is 0. So that's it. The checking is completed. So we are sure that all these answers are correct because all joints are in equilibrium. So that's it for this video. I hope that you were able to follow. It's a bit long video.